Fantastic. Thank you everyone for joining. Fantastic to have you all with us to our 9th BatteryMBA Roundtable. Time really flies. So really appreciate you all listening in, either live or watching this as a recording or as part of this current BatteryMBA cohort as well. So big welcome to all of you. We've got a really exciting panel with us today, 4 fantastic panelists. And we want to kind of quickly share with you some of these fantastic people we have with us today. So maybe Shada, you want to start introducing William?
Yeah, perfect, Simon. So we have William Berg today with us. William Berg, he is the founder and CEO of Kling Systems. Prior to starting Kling in 2020, he developed recycling strategies and designed battery systems for recycling at Northvolt. He attended Lund University, where he founded the first electric Formula racing team and studied mechanical engineering. He's based in Stockholm.
Thank you, Shada. And then we also have Ilke von Darwig with us, who works as a policy manager at EIT InnoEnergy with an industrial development program of the EBA, with a strong focus on sustainability and supply chain topics. She has been instrumental in building up and managing the vast and complex network of the stakeholders in this initiative, as well as developing the set of initial recommendations that contributed to the design and content of the 43 actions that have been identified as necessary by the European Battery Alliance to make the EU a key player in the global battery market. Today, she's leading the work in updating those recommendations to sustain the global leadership of the European battery industry in the face of the Inflation Reduction Act and other recent challenges. So big welcome to you.
So our next guest is Dr. Doran Meyersdorf. He's CEO and founder of Stordot. Doran Meyersdorf co-founded Stordot in 2012 with the mission to develop extreme fast charging battery technology utilizing nanoscale metalloids and proprietary compounds to overcome a major barrier to electric vehicle adoption, range and charging anxiety. Prior to founding Stardot, he served as senior director of SanDisk SSD business unit. Meyersdorf's diverse record also includes being the founder and CEO of InnerPresence, a Silicon Valley security software company, and co-founder and vice president business development of Shiftology, a pioneer in interactive media research. Doran holds a PhD in R&D management, a Master of Science in Information Systems, and a bachelor degree in Industrial Engineering Management, all from Tezkion, Israel Institute of Technology.
Hey.
Thank you, Shada, and great to have you, Doran. And then, last but not least, we have Ian Lauren with us. Ian Lauren is the Managing Technical Director at BNP Paribas, providing in-house minerals, metals, and materials and batteries expertise. He has worked as a geologist in Australia, West Africa, and Europe, mining development project manager in Mexico, and as a corporate executive and CEO of a Canadian-listed junior mining company. He graduated from Curtin University with honors, masters from the University of Tasmania, and recently completed a BatteryMBA certification with Battery Associates. So great to have you back. Fantastic. And with this, we want to go quickly, just a quick overview who we are as Battery Associates. We're really trying to keep this quick because, of course, we're looking forward to the panel. But just as a quick reminder, for people who don't know us yet, with Battery Associates, we have a mission to create a sustainable world through the power of people and battery innovation. We do this in 3 different topic areas: Battery EDU, where BatteryMBA is part of it as well, our educational arm; Battery Pro, which are more our professional services and consulting arm; and Battery Lab, which is our innovation arm. Just a few quick words about the BatteryMBA. Over to you, Melanie.
Thank you. As Simon mentioned, education and training make up one of our key areas, and BatteryMBA is our flagship program. For those who don't already know, here's a quick overview. It's CPD accredited, 12 weeks long program that we offer 3 times a year. We have more than 390 alumni from more than 50 countries and more than 30% female participants. Our next cycle starts January 8th, and Shada will share a bit about our participants. Over to you, Shada.
Thank you, Melanie. So our program, Battery MBA, is meticulously structured to accommodate full-time professionals, necessitating a manageable time investment around 2 or 3 hours per week. Our participant base represents a diverse array of companies actively engaging in different stages of battery value chain. Our alumni network includes professionals from leading organizations such as Tesla, Lifecycle, PowerCo, Jaguar Land Rover, Asphalt, BASF, and prominent universities, among others. And with this, I hand over to Melanie back.
Thank you. As you can see from the testimonials we've received from both past and present participants, they have very diverse profiles, from research to manufacturing to policy, and our goal is to help train this diverse and global battery workforce across the entire value chain. Have a look at our testimonials page if you get a chance, and to see how it's helped these individuals on their battery journey. Shada, want to let them know how they can enroll?
Yeah, thank you. So if you're keen on joining our program, we invite you to apply for our upcoming cohort, which commencing on the 8th of January in 2024. Additionally, we are pleased to offer a range of scholarships designed to facilitate the inclusion of individuals from groups that are traditionally underrepresented in the battery sector. So you can use the link provided in the slide and register. And I hand over to Melanie with this again.
Thank you, Shada. So DEI initiatives are extremely important to Battery Associates. One of the ways in which we champion this is through our Women in Batteries activities. We were fortunate enough last week to be able to sponsor 10 women to attend the Women's Meetup at the Future Battery Forum in Berlin, where we created postcards for the women to offer advice and inspiration for other women in the industry. Keep an eye out on our LinkedIn page for more updates on this initiative. There's been some great advice for you to see. And another way that we participate is through our own Women in Battery events. Last October, we were fortunate enough to have Dr. Crystal Waters do a fantastic Women in Batteries event. And we're excited to announce that we'll be doing this again in Q1. So keep an eye out for more details on this. Shada, can you share a little bit more about our other event information?
Yeah. If we go to next slide. Yeah, we have another big announcement. We are delighted to formally announce our upcoming annual event, Battery Day 2024. This full day online event is scheduled for 26th of September 2024. We cordially invite you to register using either our QR code or the link provided in the slide. Thank you very much.
Fantastic. Thanks so much, Shada and Melanie. And yes, now we're going to go to the panel. So thank you very much, everyone sticking with us, everyone on LinkedIn and YouTube, and again, everyone from this Battery MBA cohort here as well. And yes, we want to kind of go straight to it because there's a lot of topics to discuss. But just before, if you from the audience want to share any questions, if you are here in the Battery MBA cohort, you can just do it in the chat you have available with you right now. If you are listening in online on LinkedIn or YouTube, you can just use the chat function there and just put it on a comment function and just add your questions. We have constantly an eye on it. We want to make sure we can also bring many of your questions in here. The first 45 minutes will be public. So again, anybody here on LinkedIn, YouTube can watch it. And then the second part is only for you as this current Battery MBA cohort. So just for you to know on these topics. But with this, we want to go straight to questions. And maybe Shada, do you want to ask your first question?
Yeah, I'm looking forward to it. So the first question for William, and I want to ask William to you in the context of trading electric mobility batteries for remanufacturing and recycling, what are the biggest challenges you face in ensuring full traceability and sustainability, such as battery passport? So how do you see digital technologies aiding in overcoming these challenges?
Yeah, thank you very much for the question, Shada. And thank you everyone for having me. I'll just backtrack a little bit to give you the overview of what we're doing. And the first one is that batteries must become circular. They are not burnt, they're not used, and we're dependent on the mining and refining in a global value chain. And we have this amazing opportunity to make batteries or energy kind of endless through recycling. But then, you can, what is circularity? It is reuse, repurposing, remanufacturing, repair, recycling. So all these different steps. And so what batteries have is this cool dual ship of what's value in them. It's energy that can be used, but there's also material that can be recycled. And it's quite difficult to understand, when should a battery be reused? When should it be repurposed? When should it be recycled? So that's our kind of core. It's trying to understand, what batteries should go where. And so the challenges we face is that there's so many different battery types out there and in so many different places, and just the lack of understanding where are they. So to the first point is that, there's batteries in your phones, in power, controls, in cars, in stationary storage. So there's just all these different applications, all of which have different battery packs, different battery modules, different cells, and these all come with different just technical variations, but also chemical variations. So understanding how much cobalt, how much nickel, lithium, manganese, and all of those is in a battery system is quite difficult, because there's a lack of just understanding what's technical specifications of a battery. And the second one is that batteries are ending up wherever they end up. If you can have a typical example of your phone batteries ending up in your drawer. So that's a extremely fragmented end of life, let's say, ecosystem. And if you look on the electric vehicle battery, it ends up at either it's a take back system from the OEMs, going back maybe through warranty flows or recalls, etc. But so over time, it will be dominated by supply from car dismantlers and workshops and insurance companies. And in Europe alone, we have tens of thousands of these places, all of which receive all of different type of batteries. And so if you have a car dismantler, they can have hundreds of different batteries with different chemistries, different sizes, different degradations. And the third topic is that batteries degrade differently. They've all been used in different ways. We accelerate different, when we drive, use the different climates, etc. So it becomes this kind of snowflake thing where every single battery is unique. So how do you know what the batteries are, where they are, and what's the status of this specific battery, and how do you get those batteries to the right place? Should it be reused, repurposed, or recycled? And this becomes just a massive complexity problem that has solutions around trading, traceability, and transport. As transport is a major thing in getting the right battery to the right place. So long background story, but it's very important to understand just the problem with getting the right battery to the right place. So what we're doing at Kling is developing the software and digital solutions to enable this through a large supply and demand network, and through a very skilled trading team. We understand we can negotiate the different deals of getting the right battery to the right place, powered by a pretty vast battery data database, where so we know which batteries are in which type of cars, the modules, the cells, the raw materials inside, and can somehow create pricing structures for those. You can benchmark the raw materials towards London Metal Exchange, etc. And then it's about building smart traceability systems, understanding if a battery was in a vehicle and now it's removed, and what if it's repurposed into a second life stationary energy storage? How do we know that this specific battery is no longer an EV battery anymore, but it's all of a sudden a stationary storage? And what if the pack was dismantled into, let's say, 10 modules, and 10 modules are now reused, and 5 modules are reused and 5 are recycled? How do we know when is a battery, when does it exist and when does it not exist anymore? So we're developing these traceability systems, QR codes we put on the batteries, kind of tag them to get into our own systems, And in the long term, looking at how can we update and manage battery passports as well, so that we can terminate them when they're actually recycled. And regarding the transport side, it's about automating the documentation mostly. Shipping a battery. We're just about to publish a report or an article on the various different documents necessary to move a battery, and I think it's way beyond 10 documents for moving one battery, and having all of these different documents available to the right stakeholder at the right time, which is the truck driver, the import-export people, the seller, the buyer, the transport company, the authorities, etc. And they're kind of automating and digitizing that space of just document management in the transport sector is something we do. So that's a short story on what we do and how we use technology to kind of drive that.
Okay, thank you very much. Yeah, I loved actually how you define the battery. Is very complicated, end of life, and they're like snowflakes, each of the batteries, and you're looking for the solutions for this complex problem. Thank you very much for this excellent explanation. So I think we go with the next question now, Simon.
Yeah, thanks, William, and thanks, Sheila. I think in some way, I think puts a perfect groundwork for the next question I would like to ask to Ilka. We just had a really passionate conversation on stage in Berlin at the Future Battery Forum, talking a lot about regulation. And I think William just touched also on, why we need maybe some of these tools like battery passports and traceability to help companies to get their work done. But I guess, looking at this really evolving landscape of energy policies, how do you see regulation shaping the future of energy storage and battery technologies? What are the key policy initiatives you believe are necessary to accelerate the transition to sustainable energy solutions?
Thank you, Simon. That's also a big question, and I wish I would have the answer to it so we can predict the future. It is going to be, I think, for the European battery industry, a little bit of a rough path forward, but I think we should not forget on a lot of the good things we have accomplished getting where we are today. And I think William mentioned quite a lot of them already in his presentation and what they're trying to accomplish, making the battery industry really more circular, putting second-hand use recycling more into focus. And this was, in fact, already at the very, very early discussions we had within the battery ecosystem when we developed our battery action plan, is how we could use sustainability really to set Europe also apart and use sustainability as a competitive advantage when we create this industry here in Europe. And a lot of those discussions have led to the formation of the battery regulation that now is adopted, and that also addresses a lot of those questions on recycled content, on the battery passport, on the traceability. So I think we, in that perspective, we should not forget that we already managed to create a lot of this industry here in Europe. But when we started 5-6 years ago, I think we had all our eyes on Asia. That was the technological frontrunner. And we were busy with trying to bring this industry back into Europe and set up our own cell production. But last year, the US launched a massive subsidy program, the US Inflation Reduction Act, that is in a way a very smart subsidy program, because it combines a lot of those tools that we're currently lacking in Europe. One is the domestic requirements that are actually getting awarded in the US. And the other one is also support not only for CapEx, which we can still do in Europe, but also for the OpEx, so actually for the production itself. And looking forward on how Europe has responded so far and what might be lacking still is, at least in the short-term perspective, there have been some quite interesting proposals being presented by the European Commission. One is, of course, the temporary crisis and transition framework, the TCTF, that is allowing member states to relax a little bit on the state aid rules. And those state aid rules have been put in place to protect our internal market. So it is very sensitive subject to change the system on how we do business within Europe. And this also contains a matching clause, meaning that if you as a company want to go to the US, you get an offer and saying, this is how much money I will get in the US. This can, in certain cases, also be matched by member states funding once it is approved by the European Commission. It's still a little bit, I think, I would say, in the making, and see how valuable it really proves to maintain companies in Europe. But there are other proposals in place as well, like the Critical Raw Materials Act that now has reached a political agreement, and we expect its adoption to become before year's end. It set up targets really to address supply chain vulnerabilities, diversify supply chains, but it's lacking in some of those components really that awards financial return if you look at domestic production or increased recycled content to be introduced in your batteries. There are others. I think one of the things that I would maybe look upon with a little bit more excitement is the so-called STEP. It's a strategic technology for Europe platform that has been announced under the EU economic security strategy, which is like a EU pot of money. It's not a lot at the moment, and it's mainly pooling existing resources into a European funding scheme. And I really hope that in the next multi-annual financial framework that there will be more countries willing to feed it with fresh money, so that we actually have a more European response to the IRA, because I think this will be needed going forward, looking at how the competitiveness of the European industries has declined. Also thanks to the rising electricity prices. But I think that there's still more work that needs to be done European-wide to actually safeguard our industry. And this European-wide pool of money could be one response. I still think that it would be very interesting to investigate also in how we actually can award projects developed in Europe or IP developed in Europe, maybe by public green procurement is one way to go that we have not explored enough so far, where we can actually introduce new ways of helping supporting European companies in this race.
Fantastic, and thanks so much for sharing this, Ilka. And I think maybe later on we also go into discussions, right? Like what are the most effective vehicles? And I also have seen, conversations where other economists think maybe Inflation Reduction Act is not the most effective, right? So there's also different, and I think there's a lot of debate about each. But yeah, I think the one thing, it's definitely a very dynamic time for regulation, which is, I guess, a very interesting position to be in. But thank you already for giving this overview. Shada, I'd like to go for the next question.
Yeah, so we talk about end of life, and we talk about a little bit of regulatory landscape. Now let's talk about a little bit technology. So I turn to Doran for this question. As a battery scientist myself, I'm very curious about with this startups focusing on silicon-based fast charging lithium-ion batteries. And what do you think, Doran, what are the primary technical hurdles now you're currently facing? And how do you balance the need for rapid charging capabilities with longevity together with safety in battery design?
Thank you for the question, Shida. Thank you everybody for being here and inviting me. The technology with silicon is really exciting because it's a material that potentially has 10 times the energy of graphite. And this is because of the structure of how the lithium actually connects to the atom of the carbon versus how it connects to the silicon. And So this potential 10x sounds great, but then you have the issue of swelling. Because when the ions come in, they come in like into a balloon, and you really get a lot of expansion, can be 300% expansion of the particles of the silicon. And then when you discharge, it contracts, and then you have this breathing every time you charge and discharge of expansion and contraction. So this is a major challenge, and it took us almost a decade to kind of perfect the ability to control the silicon itself. So somebody switched off the lights in the office. They didn't believe that somebody is here that late. It's later in Israel. So the ability to really make this controllable is a major challenge. And we managed to do this by introducing new binders and conductive additives, and basically a hosting matrix that holds the silicon in place. So therefore, it's been really challenging, but eventually we made it happen. So that's challenge number one. Challenge number two is the actual supply chain, where in the supply chain of the batteries, there is always the chance that these new materials will be too expensive, or they won't be too available when we are procuring them and processing them. So building a new supply chain of silicon is also a major challenge. Now, you also asked about the longevity of the batteries. Longevity is actually also a big challenge because if this breathing mechanism is not under control, you don't have too many cycles of this fast charging capability with the silicon. And this is something that also with the help of AI, data science and artificial intelligence, over the years, we kind of pinpointed the formulation and the right permutations of the material that would actually enable us this balance between fast charging, longevity, and also the cost that I've mentioned. So it's really a very short blanket that you're working with a car maker, and one of them is more interested in more energy, and one is more interested in cycle life, depending on the use case, and the other one is most important for him is the cost. So all these parameters is something that you constantly optimize for different use cases of the car makers.
Yeah, excellent. So how fast actually can we get to charge our batteries soon? Do you think it will be like 5 minutes charge would be possible with silicon anode?
So 5 minutes, really, the bottleneck will become the charging station.
Yeah.
So we have today 350 kilowatt power. This is like the really high end of Electrify America, EVgo, those guys. So with 350 kilowatt, we can deliver what we call 100 in 5. That's 100 miles for each 5 minutes of charging. So it's not 5 minutes for the entire pack, but maybe half or less of the pack. As we go through our generations, we will get to 104 and 103, and our holy grail is 102. So that's like two minutes for each 100 miles, which give you a full charge in about 5 minutes, like yours. But that's a decade away, I would say.
Okay. Thank you very much, Doron. Excellent.
Thank you.
So I hand over back to Simon.
Thanks, Doron. Thanks, Jada. And maybe to Ian. Now we spoke a bit about some of the technology, and we spoke about some of the regulation. Of course, it's also about the money and about financing, right? And Ian, we're very lucky to have you because you have a perspective from the finance sector, and also, but actually, you have seen also upstream, right, like through your mining experience. So maybe it'd be great to hear from you some of what you think are some of the critical factors in financing and supporting the growth of sustainable battery technologies, and especially also with this more widely discussed vertical integration in the battery sector.
Yeah, no, thanks, Simon. Thanks to the previous participants in their presentation, because it all at the end of the day, it does all come down to, can we commercialize these technologies? Can they become a regular product into our society, and the aim is to decarbonize. We've already understood that by removing the ICEs, the vehicles, carbon-based vehicles to EVs, we have the technology to do it, as some would say. Obviously, the battery technologies have gone in leaps and bounds, but we've recognized that there's an issue in terms of bringing it to a commercial scale and throughout the whole vertical value chain. From my perspective, having been involved in everything from mining, minerals, conversion to active materials, it's been a challenge for that industry to try and be ready to support the battery development and the battery value chain. And so from that, it comes back down to, well, how do we support that from a financial perspective? And the two main, obviously, trains of financing is through investment and through financing through debt and equity. The concerns is the investment from an equity perspective is certainly based on return on investment, and therefore the cycle time, to pardon the pun, to develop these projects is going to be a challenge for many equity investors. They find that to be I guess a difficult decision for them to make. The risk in getting a return on that investment is something they will always have to consider. And then from financing, I dare say the whole battery industry is actually a victim of its good, I guess, brilliant development, in that research and development has gone in such leaps and bounds that it's been hard to find a common landing ground to allow financial institutions to be comfortable and say, let's finance this. Financial institutions like the commercial lending groups like BNP and the others have a need to be comforted on a risk profile where there's a steady state of production, a common production, so the technology roadmap doesn't change on you, that there's an ability to produce at a commercial scale, obviously with margins, but to have revenue and be able to service any debt. That's always been a challenge, and it still remains a challenge. And a lot of the gigafactories that some of you know and love in Europe are going through those teething pains and growing pains, which is fine. And thankfully, within Europe, and Ilka's part of that ecosystem as well, but through the development banks like the EIB and UKIB, also the NIB and EBRD, helping throughout that whole vertical value chain, be it the miner, the active material producer, and even the cell manufacturer, to I guess provide some guarantee, some state guarantee and support. And through that, with the export credit agencies like BPI, SACE, Euler Hermes, UFK, and alike, that makes can help with the financing. But yeah, it is a challenge, and of course Europe is very committed to a responsible sourcing and sustainable approach to producing its batteries. And the biggest challenge is obviously the raw and active material supply part of that value chain, where I think Europe has got the downstream under control, if you like, and Ilka's already addressed those points. It's the upstream where, and the European Critical Raw Materials Act has come in with some metrics to how to optimize what can be brought in. Recent accords with Canada, with Australia, with other countries, Chile, to secure those key minerals, metals, and materials for the battery sector: lithium, graphite, nickel, cobalt, even in some cases high purity manganese and phosphate. So anyway, so to cut a long story short there, in response to your question, Simon, yeah, no, the financing, be it through debt or investment, with equity, the challenges are definitely there. There is support to get in there, but because the battery sector is evolving at a rapid rate, it's sometimes hard to find a place to land and have everyone on the common page to then follow through. So, and I'm sure that'll probably raise a few questions on the board today. Cheers.
Thanks so much, Ian. And yeah, really great to have this perspective. I think it's a fascinating one and a very important one. Often, I think, doesn't get enough appreciation. So really appreciate these insights and thoughts. So then also just want to remind everyone, if you have any questions, feel free to put them in the chat. So keep them coming. Thanks also for all the BatteryMBA participants here in the live cohort. So free to share them. We're also going to go many of them in the discussion we have once the live stream ends. But also everyone on LinkedIn and YouTube, for free, if there's any burning question you have, anything you want to ask these fantastic panelists, please add your questions now, because we have another 10 minutes or so with them all here live. And now I think, Shada, you have a question for the entire panel.
Yeah, exactly. Thank you, Simon. For my next question will be for the entire panel. So how do you envision the collaboration between different sectors like finance, policy, technology, and manufacturing in advancing the development and adoption of sustainable battery technologies? And can you give an example of sustainable collaboration or one you would like to see in the future?
I can go.
Yeah, perfect, William.
And okay, it's touching on your area, also on your area, regarding where used batteries go. It's about, if you take it from a European perspective, we are all quite nervous with how we secure a reliable supply chain, as we're quite dependent on non-European supply. If you look at from a end of life perspective, and looking at where recycling is developing and where raw materials are going, what we see, as we're a global trader of used batteries, we see a lot of demand from non-European players, Southeast Asia, and increasingly in the US for raw material, basically buying used batteries. So this is it's not even hidden. It's like this massive flow of used batteries not reaching end of life in Europe, or if they do, they're exported as either being shredded here and sold as black mass to refineries outside, or just sold as used batteries. And the issue here is that, one, Europe is quite, we don't have the funding of keeping the batteries here. The offers from US and Asian players is just far higher. There's no reason for anyone who owns used batteries here to sell it or even pay for recycling here. And what I see as an actual problem is that you need feed to your recycling processes to fine tune it, to develop it. And if you don't get that, you're not going to fine tune and develop your recycling processes. And so what's happening here is that we might just basically lose the recycling game, because the batteries that go to recycling in Asia and in the US, they're going to get better and better, and they're going to be able to offer higher and higher prices, because they produce better and better raw materials. While in Europe, we don't have the supplies, we cannot get better and better. And so it's this kind of takeoff supply that is currently going to US and Asia, that we just cannot see here. And it comes down to good policies so that we can build faster in Europe, but also just the capital to basically subsidize recycling here, to get kickoff of getting the recycling off the ground. Because currently what I see is that the offering from European players is just far out from the offer from outside of Europe, and I'm genuinely worried about European recycling is ever going to take off without proper regulations and proper financing here. I know, Ilka, if you kind of think about that. Also, on the same thing, with new quotas for recycling in produced batteries. If we cannot keep the batteries here, then we're going to be ever more dependent on buying recycled material from outside of Europe, and then we're dependent on buying raw material from outside, but also forced to buy recycled material from outside. And we just need more recycling here, but also just financing it and getting the money so that they can actually pay for these batteries. So it's a market.
Yeah, thank you very much, William. Yeah, it is very important for us in Europe, that multi-sector collaboration to kick our recycling efforts forward. But yeah, as you mentioned, we're falling behind for the moment, comparing to Asia and US, unfortunately. But yeah, hopefully, yeah, we will be getting better in that soon. Anyone wants to take at this point? Anyone wants to comment on this question from the panelists?
I can follow up on Williams, that I fully second. I think one of the big issues that we are currently looking at in Europe is really the leakage of material out of Europe. That is something that we urgently need to tackle. There's, of course, a difference also in price that William already touched upon, that currently it's also that that you're getting better paid for the for the black mass in Asia compared to what European players can play, and this has to do that they are so much better already at recycling that they get much more material out of it, and we still need to learn all of this. So collaborations was the initial question. I think along the entire battery value chain is something that we have seen is really doing the trick for Europe. I think Northvolt and many others of the, and Vercor, ACC, would not have advanced so much if they wouldn't have worked together with the OEMs together. And many of those initiatives that we have seen that failed did not have this collaboration with their off-takers. And I think what we need to look is now to establish the same kind of strategic alliances also in the mid and upstream sector. And looking also on the raw material side, how can we become better? And then it is not only a European question alone. We also touched upon this, that we need to source our material from elsewhere. But there are good opportunities to also do research. It was just announced that Canada is invited to join Horizon calls in Europe as well on materials specifically. I think this is extremely good news, and I hope that other countries will follow, because we will need both the exchange on technology, but also access to the resources.
Yeah, thank you very much, Ilka. Yeah, especially you touched on the leakage of materials from Europe, and collaboration and strategic partnership within Europe is key within the battery value chain. Is there any more comment on this question from the panelists? If there is not, I think we might continue with the next question. I hand over to Simon for that.
Thank you, Shada. Yeah, and there's a couple of questions coming in over LinkedIn and platforms. So I think some people had some issues with posting it, but if you do, feel free to just reach out either, to our Battery Associates LinkedIn account. There's a few questions coming in there directly, but also in the comments. So there's a question on mining as well. I'm saying this is quite a challenging topic, and maybe it's something for you, Ian. You could maybe add on a bit. People talking about it's highly regulated, quite expensive, long timelines, I would add myself, for getting these mines set up. So how can this be done? What strategy should companies or battery companies take on securing the raw materials?
It's a tough one, Simon, because what's happened is that the cell manufacturers, firstly, it's usually the mining companies that have sort of gone downstream a bit because they've taken the initiative. So a lot of them have been able to produce more refined products rather than raw concentrate in the past. So now we're seeing a lot more in the production of lithium chemicals as well as lithium salts, be it hydroxide or carbonates. We're seeing more refined and high purity nickel and precipitates and nickel, and also in manganese. We're seeing graphite now, so a lot of companies are now going all the way down to an anode active material, even looking at blending with synthetic. So there's a lot more of that going on, but they're all trying to get that high value product in the hands of the end producer who have the means to invest, which is usually those OEMs, be it vehicle EVs or energy storage systems or other industrial players. And the cell manufacturers and the precursor and CAM and anode active material manufacturers above them are sort of caught in the middle, are having to do the work on behalf of, which is sometimes a bit complicated. A lot of pass-through strategies when it comes to pricing. And we can take Northvolt as a good example of a company that started off trying to secure their own raw material directly in a sustainable way, trying to secure the products and the minerals and metals and materials from known entities who have a reputation of being responsible miners, responsible refiners, and that's been a positive and probably a very important reason why they were able to be financed in a secure way in Europe. But then we see the Chinese cell manufacturers, and CATL has entered into Europe quite calmly, nicely, without anyone really bothering them. There's still a question mark on where most of those raw materials are coming in, but hey, they're coming into Europe. The challenge is, in fact, how to support those miners which have a reputation of being responsible and operating in jurisdictions where you can execute, where, as you said, the timelines which are already quite long, can be addressed in an appropriate, methodical way, where all of the ENS aspects are addressed to the highest levels. That's what we're all after, and certainly within Europe, that's what's the aim, the challenge, to provide the right raw materials and active materials that are responsible, done in a responsible way, and then producing a battery cell as well in a responsible way, and going all the way through the value chain to recycling, which is what William had addressed earlier. And that, the recycling discussion is also an interesting one. I guess we're in a situation where at the moment we're trying to get EV penetration rates to increase, which means cell manufacturing increasing and increasing. So we'll get more and more batteries produced, and then once they will reach some sort of critical mass, again, pardon the pun, where there'll be a need for recycling anyway. And the recycling in Europe is going to have to step up, and it will. Some of them will be latched on to existing cell manufacturers anyway. It's more a question of getting it responsibly in and then not letting it leak out. And the financing for that is also another, as I mentioned earlier, it becomes a challenge because those lead times aren't synchronized. It takes a long time for a mine to get product up, but only a couple of years, 3 years for a gigafactory to build and start producing cells.
Thanks so much, Ian. Maybe there's 2 more questions I want to bring in from online on LinkedIn, etc. And then we're going to wrap up the live stream pod. But just, I think one as a follow-up for this, Ian, with you, and it's talking about from a material side, right? So kind of if the reliance of materials such as lithium will actually be reduced, critical minerals there now with future technologies, right? I guess topics, sodium ion, etc. If you've seen anything there, if there's if maybe it's less of a challenge people think it might be going forward.
That's a tough one, because it comes back to that technology roadmap discussion. The R&D in battery cell manufacturing, and Doran's a good example of that, is going in leaps and bounds, and everyone is coming up with new and improved versions. Sodium ion is now starting to be a real potential option, at least on an energy storage system approach, even if there's questions regarding its energy density. We're seeing LFP cells coming back to the fore principally for no other reason that it's cheaper to produce, because iron and phosphate is easier and cheaper to produce than any chemistry from a nickel ternary cell. So that too is becomes I guess a discussion point. There's no, everyone wants to provide the latest and greatest cell and highest performance battery, which is normal, but that time to commercialize it and then to obtain the financing, to have the right equity partners, at some point there needs to be a line in the sand and say, right, we will. And some have done that. The OEMs have done that. They've all gone with an NCM technology here in Europe predominantly, except for Tesla. And Tesla in general. I mean, they have got some NMC in there in some of their models, but it's more it is trying. Everyone's trying to juggle the different, I guess, opportunities, and I know there's no real shortcut answer, except that at the moment what can be delivered is coming predominantly from Asia and China in particular, and we either try and accept that technology and maybe force more reliance on the sourcing than overdoing it in the R&D. But and again, putting just a bank's hat on, the bank just wants to be able to finance a project that it can service a debt facility, and because it can produce cells on a almost production line approach for a period of time to meet its customers' demands. But sodium ion kicking in, yes, that's a new kid on the block. We're hearing about other zinc air and lithium anode, silicon anode. It goes on and on. It may create niche markets everywhere, but I'm not sure how that can help in terms of penetration, in terms of rolling out the EVs, and more importantly, getting the ICE vehicles off the market. Just a personal view.
Fantastic. Thanks, Matti. And there's one final question from online, maybe for you, Ilka, more on the regulatory perspective. Celine, what is the likelihood of America and Europe collaborating on regulations such as bringing the US IRA and the European Green Deal together?
Well, I think there are other topics that might be easier to work through. I think there are aspects in both the advancements of the European Green Deal and the IRA that are actually looked upon by both regions. One of them is the development of a battery passport. It's from very different motives, I would say. I think in Europe it was much more driven from a sustainability angle, supply chain transparencies, also to be able to track the raw materials in the battery. And in the IRA, interestingly enough, the domestic requirements, in fact, to be able to get those incentives, you need to prove where your material comes from. So all of a sudden, the concept of a battery passport becomes economically attractive in the US. So discussions have started to at least have the same kind of baseline. So being a global industry, I think we need to adapt some of this. There have also been discussions on raw material supply between both regions. There's this raw material club that has been established at an institutional level, but I think also the industry is quite keen on trying to kind of find a common understanding, so we're not competing on this part or this end of the value chain. So having a complete alignment between the Green Deal Industrial Plan and the IRA might not happen, but I think in certain aspects there are areas of collaboration which, at least from an industry perspective, makes a lot of sense as well to talk to each other.
Fantastic. And with this, we want to close the live stream, at least the part. So we're now going to go into the BatteryMBA cohort only part. But again, massive thanks for anybody who joined us, either on LinkedIn or YouTube, or anybody else watching the recording later on. Last word, maybe just on the BatteryMBA. Next course starting 8th of January, and the sign-ups close on the 15th of December. So you got about 2 more weeks if you want to join this upcoming cohort. If you have any questions, just get in touch with us via the website or LinkedIn or so, and hopefully see many of you there as well. But with this, thanks again, everyone, for watching, and we're going to start